The first thing that I want to talk about with today's lesson is operations with functions. So just like we can add, subtract, multiply, and divide numbers, we can also add, subtract, multiply, and divide functions. So for example, if I say that f of x equals 3x minus 7 and g of x equals 13 minus 2x, and I want to find f plus g of x, I'm going to take what each of those equal and combine them using the operation that was noted, which in this case is plus. So I'm just going to write these down and then combine my like terms. So my like term with 3x is negative 2x. So 3x minus 2x gives me 1x. And then negative 7 plus 13 is going to give me 6. So x plus 6 is my answer here. But since I'm combining whole functions, the way that we write the new function or its name is going to be f plus g of x. So what this is telling me is that these are the functions that I'm combining. I'm combining f and g. And then this little guy, the of x on the outside, is telling me that they're a function of x. X is my variable. So let's look at a little bit more notation. So I have the sum, which is what we just looked at. We also have subtraction, which is where I say f minus g of x. I have product, where I say f times g of x. And I have the quotient, where I say f divided by g of x. Now the reason that difference and quotient have a little line next to them is because for these two, the order matters. So the first one, the first function, minus the second function is different than if I were to say g minus f. And the reason being is because division and subtraction are not commutative. So 2 minus 3 is not the same thing as 3 minus 2. Or 10 divided by 5 is not the same thing as 5 divided by 10. So be careful with those. Sum and product, those are both commutative, so f plus g of x is going to be the same thing as g plus f of x. So let's look at a few examples. So let's say that I have the function f of x, g of x, and h of x. If I want to find what f plus g of x is, I'm going to take my function f, which was x squared minus 8x plus 4. And I'm going to take my g of x function, which was 4x minus 3. And I'm going to combine them through addition. So I'm just going to combine my like terms. X squared doesn't have a like term, so we're just going to bring it down. The like term with negative 8x is positive 4x. We combine those, we get negative 4x. And then positive 4 and negative 3 is going to give me a positive 1. So f plus g of x is going to equal x squared minus 4x plus 1. So B says that I'm going to take my f of x function again. So I have x squared minus 8x plus 4. But this time I'm going to subtract h of x. So subtract h of x, which was x plus 2. So what I need to do here, I'm going to bring down my first function because nothing is changing here. So I can go ahead and drop those parentheses. And then I'm going to distribute this negative to both terms and get negative x minus 2. Now we're just going to combine our like terms. Bring down the x squared, negative 8x minus x is negative 9x. And then positive 4 minus 2 gives me a positive 2. So here's our answer for f minus h of x. So now I have h times g of x. Let's see what h was. X plus 2. And I'm multiplying that with g of x, which was 4x minus 3. all I need to do here is multiply by double distributing. So x times 4x is going to give me 4x squared. X times negative 3 gives me negative 3x. 2 times 4 gives me 8x. And 2 times negative 3 gives me negative 6. Combine your two middle terms, and we get 4x squared plus 5x minus 6. And then the last one, we have f, which was x squared minus 8x plus 4, and we are dividing that by h, which was x plus 2. Now, for this one, we're actually not going to simplify. There are a couple cases where you could simplify. We're not necessarily going to be looking at those today. And something else that you might want to look further into if you plan on moving to college algebra or anything above that is this is actually going to change the domain of your function because you're going to have some restrictions due to that denominator. So I want you to try out the next two problems on your own and see how you do.